Well, hello everyone. But if you bought something that was used, you better go ahead and charge each individual cell separately to a full state of charge before hooking them up together. Today, we're going to be talking about charging batteries, charging the cells, charging the modules, charging your BYD pack or whatever you purchase used off of internet. The reason why we're talking about it is, I think, and I haven't seen it on another channels that I visit too, is these cells appear properly fully charged. This battery that I made over here, it will appear that is fully charged, as you can see. Right? When we measure each individual cell, it will show up as almost equal voltage on each cell. All right, here we go, just so everybody can see. About 10 to 20 millivolt difference between these cells. And they appear like everything is just fine. That's majority of the times what happens when you buy used cells. Now you have two options. Okay, if you're buying a cells like I did, each individual, you can go ahead and charge them. Charge each individual cell separately until fully charged to 3.65 volts, or if you are impatient like me, you can assemble everything and then try to do it later once everything is done. Okay, now as we saw, these cells appear to be fully charged. Okay, and it seems like we can put them on a charger and finish charging them off, make the full battery. Okay, over there, and make a battery full. Now over there on the little power supply, I set it up 14.5 volts, almost full. 14.6 will be full. Okay, now let's do a little experiment. Okay, we're gonna start charging. It appears that it's charging at 9.5 amps. Right now, after a while, we will have to go and check voltage of each separate cell. Now, how can we do that? There's a couple of ways we can do that. Okay, we can check the whole pack, which is already has jumped to 13.46. This is difficult to do. Jumped to 13.5 already. Or we can go ahead and check each cell separately. Okay, now, all right, so let's check the first cell. So the first cell is at 3.39. Second cell is at 3.41. Third cell is at 3.37. And the fourth cell is at 3.37. All right, we'll give it some time. 3.41. 3.49 already. 3.39 and 3.38. Total voltage 13.75. Now we already starting to see a deviation. Seems like that cell number 2 will charge itself faster. Now why am I talking about this? Cells might appear, as you saw in the beginning, might appear to have a same voltage. You would think That will be a same capacity of charge. Actually, it might not even be close, as you will see real soon. Why am I talking about this? Again, I'm talking about this because cells might be at a different level of charge depending when it was manufactured, how long it was sitting somewhere, has it been used, was somebody using it in a cold weather, was somebody using it in overly hot weather when it was being used. Okay, let's check cell number 2 again. It's at 3.73 volts already. I am already above what it's supposed to be. You're already starting a damage on one of the batteries. I'm gonna stop it. Let's talk about it. So all of you guys that bought already pre-assembled battery packs, those 24 volt and 48 volt, whatever, BYD batteries, or some other type of a pre-assembled used battery, be careful. You have to charge each cell separately, or if it's already assembled, you would have to charge each cell by itself. So you might say, okay, I already have this pre-assembled, what am I supposed to do? Well, we can do this, and I will show you example of what to do, and then how we're gonna do it on a giant assembled pack already. Okay, so what we're gonna do is we're gonna go on load power supply. Okay, let's check the state of charge. 3.43, 3.72, 3.38, and 3.38. All right, so now we already know that the cell number 2 is fully charged. We have seen that, and your batteries, be it new, be it used, some of them might be on a different level of charge, depending was it used, when it was made, how old it is, all those things. So what we can do is, even if it's assembled like this, what you can do is charge each cell separately, even it's already assembled in a battery. Okay, so this is the cell number 1, and it's drawing 3.71 amps, and it's charging 3.45 volts, 3.446. Okay, and it's taking in 3.67. Once it reaches 0 amps on lithium iron phosphate, you're done charging. Okay, let's try to go to cell number 2, which is already charged, and this cell was appearing to have the same voltage as other cell, or fairly the same, right? So let's see how much charge it will be taking. I'm thinking about none. Just look at the amp meter on that little power supply over there. 0. It's fully charged. There's no reason to molest it anymore, right? But if you keep it in the series and then you try to charge series, you're just going to damage it unless you have a BMS that can stop you. That's why the BMS is very important, and everybody should have one on their batteries. I don't care what kind of battery you have, you should have some kind of a battery management system on there, especially when we're dealing with such a high energy capacities as we do. So let's see how much this one will be taking in. Check this out. This one is even at the lower state of charge than the cell number 1, which was only taking 3.69 amps. So this one is even at the lower state of charge than the cell number 1, while the cell number 2 is fully charged. Okay, and here we come to cell number 4. So the cell number 4 and cell number 3 could be charged. They're almost at the same level of charge. While the cell number 2 is fully charged, and then this cell is charged less than a cell number 2 and more than the cell 3 and 4. All right, now what's next? What unconventional thing you can do? All right, now this is easy to take care of, right? This is, maybe you can disassemble it and charge everything. What if you have everything assembled already and you have one giant Powerwall like I do? Okay, like I do. What can we do in my case? All right, let me show you my unconventional way with 2 power supplies for the whole Powerwall. All right, guys. So this is just to show you that this Powerwall number 3, I'm going to be using it as example, okay, is turned on. Powerwall number 2 is turned on. I'm going to turn it off. Okay, and then Powerwall number 3 is already turned off. All right. Now, just remember, I already did this in advance before I'm deciding to make this video today. I already did charged Powerwall number 3 fully. Okay, if we look at this little balancer / monitor, I have a 30 millivolt offset, okay, between the highest charged module and lowest charge module. The highest charge module is module number 6, which is 3.553 volts, and the lowest charge module is 3.53 volts. And then now I can turn on balancing function, which will work pretty good with this little minimal difference between the cells, okay? But if you have state of charge that is way out of whack, I'm talking about many amps out of whack, many amp hours out of whack with each other, what can you do? Well, the battery is in a float right now. Other 2 Powerwalls are turned off. And let's say you have only one Powerwall and you do want to shut it down. So it's already on a float. It's already been done. What can I do to raise the voltage of that one cell? And let's just pretend in this case that there's many amp hour difference between these. Okay, we can introduce the outside power source directly to a fending module in my Powerwall. Okay, so I'm pretty sure you guys want to see that. So let's demonstrate that. Okay, so we did talk about module number 10 in my Powerwall is the lowest charge module. Okay, so the 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the offending cell. All right. So what I'm going to do is show you this one more time. Cell number 10, right? I'm going to introduce a charge to cell number 10, and we are going to be at 3.6 volts, and then we are going to try to charge that cell up. All right, so here you go. Here you go. All right, it's charging at 2.15 amps. Okay, and if we look over here, the voltage is already starting to be raised on that one specific cell. There you go. You switch right now. It's up at 3.530. The cell voltage differential, it's already down to 23 millivolts. The cell number 10 has exceeded 3.528529 where it was already. Okay, and the battery is in a float mode. It's charging. It's already down to 1.96 amps. So, in conclusion, if you already have a Powerwall pre-assembled and it was made out of used batteries, or it's a used Powerwall or battery pack, okay, there's a module number 10. It's already at 3.54 volts. If you have used battery pack, you might need to go and charge each cell separately without hooking it up to whatever your system might be, 12, 24, 48 volts, 60, whatever your power total voltage might be. You might need to go and charge each cell separately. As we can see, the module number 10 is already at 3.549 volts. Okay, so what I can do is disconnect this outside power source, turn it off. Okay, you will know when the cell or the module is fully charged. Now I'm doing this just as an example, telling you that even if your Powerwall is already hooked up and it's in a float charge of some kind, you can still go and charge each module and each cell individually if you need to. You just need to be careful and pay attention to what you're doing. You got to know where the positive is. In my case, positive, negative, hook up the leads and introduce. Okay? In the same way, which another thing you can do is, if you think you will achieve something, you can introduce a resistor and you can discharge some of the cells too. You just go straight to the cell, whatever the cell might be, or a module, and you can discharge it that way too, if they are charged too much. Okay? So just because cells appear to have a same voltage doesn't mean that they are on the same level of charge. That's how majority of balancers work. I don't care which one. It can be a Batrium too. It still works on a voltage, but it does not know what the state of the charge of that battery is. It might show up, as we saw in the beginning, at 3.35 volts of majority of those cells, but then one cell reached 3.75 like in 1 minute. It might be misleading just checking the voltage on the batteries. You need to see the true level of charge. You can see that by hooking up. You can see that by hooking it up to a charger that will display how many amps it's taking in. Okay? Pay attention to your batteries, especially if you have a used batteries. Even if you have a new batteries, you gotta learn your battery pack. You gotta learn each cell on individual level. There is no going around it. You have to do your due diligence, especially if you're doing it yourself. If you're buying a Tesla Powerwall, let Tesla deal with it. They have awesome warranty. If somebody else builds your Powerwall, have them deal with it. Better be brand new batteries. But if you bought something that was used, you better go ahead and charge each individual cell separately to a full state of charge before hooking them up together. Or in this case, if you already have it pre-hooked, you can go and charge each cell or a module by itself. I have modules because I have three cells in parallel, making it as a one module. Then 16 modules hooked up in a series. Okay, hooked up in the series. And I do have a balancer, which I'm going to use right now to balance it out a little bit. But majority of the time that balancer is used as one beautiful, phone control balancer slash battery monitor. Alright guys, thanks for watching. I hope you learned something, and I hope this video was not boring as it could have been.